today I'm going to be taking you through different critical capabilities, different features, some good use cases for virtualization, and help you understand those pieces of technology that are going to be vital to a successful rollout. So I think the first thing that's important to talk about when choosing the right service virtualization is service virtualization itself. And when talking about service virtualization, I like to use this analogy. In our houses or places that we work, we have faucets, we have sinks, right? Things that give us water. But if you think about this, a faucet's kind of an interesting thing to test. How would you actually go about validating that a faucet is working properly? Well, the short answer is that you would go to the faucet, you would turn it on, and if water came out of the faucet, then it's working appropriately. If water doesn't come out of it, then something's wrong. But it's not actually as simple as that. You can't just go down to the hardware store, go buy a faucet, open the box, turn it on, and see if water comes out, right? You need an entire infrastructure behind the faucet to support that. So let's peel this back a little bit. And so typically, you would test a faucet that you're either building, adding a new faucet to your house or replacing an existing one. You'd have to hook it up to the entire house. And there's all sorts of back-end plumbing that's required for that. But the reality is you don't actually need the entire house to test the faucet. What you really just need is something that can supply water to it so you can validate it. This is really analogous to our applications. When it comes to testing a specific piece of functionality, we don't need to build the entire house. No, we just need to focus on the thing that it is that we want to test, our new application, our new service. So service virtualization allows us to create simulations of all of the back-end necessities, all the different pieces of plumbing that we would require. And then we can generate a test against our specific or unique application. It would then call out to the simulation. In this case, it would call out to a water source and simply supply back exactly what that faucet needs in order for us to successfully validate it. And so this is really what service virtualization is about. It's about allowing you to do more focused development, more focused testing without having to build the entire house. But when we think about this in the context of our applications, it's considerably more complicated because there's really two sides of the equation. And in our applications today, we have multiple interfaces that we expose new functionality across: mobile devices, web portals. Users can create applications to communicate with our APIs. And these are all interfaces to our technology. And it's a little complicated to understand how to test all of that. Now, there are solutions out there like Appium and Selenium, Postman, that allow us to create tests against these individual interfaces. These are great, but they typically require a little bit of development knowledge to understand how to use them. And so this is where functional test automation tools allow us to simplify the process of creating not only functional test automation, but also non-functional scenarios. And they can do things like execute our existing scripts or create their own proprietary technologies to test across multiple interfaces and string them together, as well as leveraging those for our performance and security testing. Now, a while back, we did a webinar where we focused exclusively on this, which was helping you choose the right API testing solution. So if you're interested in this side of the house, I encourage you to check that out on the Parasoft website. Now, once an organization has successfully implemented functional test automation to validate their interfaces, really what happens is that the challenge shifts to the back end, that entire house of plumbing that you need in order to support this application. And you can have challenges back here where some of these services may not be available because they're currently being developed. Maybe there's a charge or a pay-to-play interface on them that says you get charged every time you use it. Or maybe you're trying to do something with a service to validate some new functionality in your application, and that backend service has never done that before. And so you need to put in some behavior that typically wouldn't exist. This is where service virtualization comes in. And so for our testing, it allows us to stabilize our test environments by providing simulated representations of all the different services we may need for an automated functional test or non-functional test workflow. And it allows us to not only supply those expected the expected behavior that we want, but also to push the boundaries of what's possible in our test environments by providing negative or malformed responses, potentially a security exception. These technologies, service virtualization and functional and non-functional test automation, can be tied together with test data, allowing us to have the right test data for our functional test automation and leverage that inside of our service virtualization solution. Moving into the era of DevOps, that allows us to take more of an environment-based approach to testing, where we define the test environments via virtual services or a combination of live and virtual services, and then package those all up together with our functional test automation so that we can create a templatized representation of a test flow. And then either hand that off to an individual tester so they can test unconstrained from the environment, or orchestrate it as a part of our CI process so we can create dynamic test environments with virtual services. Whereas a function of code check-in, whenever a new application is available, we can then orchestrate that either on-premise with normal hardware or using containerized solutions like Docker and Kubernetes to spin off copies of these virtual environments for our testing needs and configure them in the way that we want in order to enable us to have greater test results. So these are the ultimate advantages of bringing service virtualization into your automated testing practice. But in order to get there, we need to understand all of the different tools and capabilities that are available to us so that we can choose the right one. Well, if we look at the tooling landscape, it really breaks down into two different types of solutions that are out there. Typically, you'll see your free or open source solutions. These are often referred to as the lightweight tools. You'll hear a lot of terms like mocking or stubbing in this area. And these are great solutions because obviously they're easy to pick up and they allow us to do basic stubbing, static responses to build a simple virtual service for a use case where we're just trying to unblock a component. It's internally customizable because in a lot of cases these are open source, and so the organization can actually contribute and change the code base. A lot of them are free, potentially in the short term. You can see that in these areas, though, sometimes you have a challenge when it comes to covering the breadth of your application. Because while there are free and open source solutions, I think, for everything you might need to do, all the way from maybe simple HTTP, SOAP, REST, but when you start getting into things like queuing technology, microservices, different types of file operations, and different proprietary protocols, that internally customizable thing turns into a little bit of a challenge because now you have to maintain them yourself. So on the other side of the spectrum, we have those enterprise tools. A good example of this would be CA-Lisa. The idea is these are heavy hammers that allow us to do comprehensive virtualization across the organization. They're built with scalability in mind. They have many built-in message formats and protocols. There's a governed process that allows us to understand the different policies and procedures to use these solutions. And of course, they're vendor supported. So as new message formats and protocols become available, they become available. Downside to these tools is they're not free, they're expensive. And so you have to first have a commitment to quality, and you want to bring service virtualization to the entire organization, and then choose the appropriate one. And so this is kind of the two different sides of the spectrum. Obviously, there's a blending across this tooling landscape. And when most people come to me and they ask, what kind of service virtualization do I need for my organization? There's a very interesting piece in that question, which is my organization. And it means there isn't one answer to this, right? Ultimately, you need aspects of each of these types of solutions so that you can tailor something that's right for your organization, your needs, the things you are doing. And so I think that a good way to look at this is to break it down to the different features and capabilities that exist in service virtualization solutions. I break this down into these 5 categories of ease of use and capability. Those features that allow an organization to easily pick up service virtualization and rapidly integrate it into a part of the development and testing process without too much disruption, without too much ramp up. Then you have optimized workflows. Optimized workflows are those things where there are activities you're going to be doing all the time. For example, message routing, or creating a new virtual service, or updating a virtual service. And you want to be able to have features and capabilities that allow you to focus on those things and do them rapidly, and take a lot of the guesswork out of them. The middle column here is all about supported technologies. There's many message formats, many protocols, many ways to interface with the different APIs. I'm going to go kind of deep into this one today. This is where you're going to want to look at the technologies that you're implementing and figure out exactly which ones will be important to you. And then automation. You want to be able to build service virtualization in as a part of your existing automation or DevOps process. And so having a solution that has built itself in such a way that it can be interacted with, invoked, provisioned, used without human intervention is going to be very important. And then the last column, which I think is some of the most important pieces, is the governance, the management, the maintenance. Being able to have a scalable solution that isn't going to overburden the team that has been designated with doing this, or an individual that's doing it. And so there's some key pieces that you'll need in this. But the question you need to ask yourself is, what do you need from this list? Because it's different for different organizations. I think a good way to look at this might be to look at industry verticals. So let's say that you're a financial organization. There's some things that will be really important to you because you're going to be interested in privacy, making sure that legacy financial interfaces such as mainframes, fixed length messaging, maybe proprietary message formats such as fixed and Swift can all be virtualized, as well as being able to have it picked up by a broad organization. So having it visual and scriptless so that we can bring it in and help technical and non-technical users understand what's required to create virtual services. Because of things like open banking and all of the new APIs that's bringing, we're definitely going to want to be able to have a high level of logic and service reusability so that we can leverage work that we've done in one area to power potentially an open banking sandbox. Authentication and security, such as OAuth and SSL, are going to be really important in this area. Being able to not only communicate with those systems so that you can gather that initial traffic, but also to be able to emulate systems with the proper authentication and security so that you can verify that as a part of your automation. When it comes to automation, things like command line execution, build system plugins are going to be important because we're going to need to be able to have these services available to us on demand with the current versions. And so to be able to swap all of that in will be critical. And I see in a financial organization, the management and maintenance side becomes hypercritical because typically you might be building a center of excellence. And so you're going to need to have high-level global configurations for environment templates, virtual service templates, and all of that rolls up into governance and being able to build the best practices into the solution, as well as having a rigorous change management process. So these may be the things you're looking for when you're in a financial organization, but it could be completely different if you're in a different type of organization. So for example, in telecommunications, you may be more interested in performance testing. Make sure that streaming things work. And so things like variable performance delay and validating that your virtual services can be clustered and scale appropriately to emulate the performance of your real systems may be a critical piece to you. Message routing and failover to live systems so that you can, as new technologies are being built into the environments and are taking advantage of things like microservices, that as these services are changing and we're redefining how the message flows work. The virtual services give us the ability to rapidly reconfigure that at the same time. And so from a supported technology perspective, IoT and microservice protocols like Kafka, WebSockets, AMQP, some of these new and emerging technologies may be important to you, as well as web page virtualization, which is a new and emerging topic I'm seeing a lot. In telecommunications, I've actually seen a lot of requests for cloud support so that we can create virtualization as a service, make it available to dynamically deploy into a cloud so that it can be used by multiple teams across separated geographic locations, and then a browser-based access to the solution. So kind of the same, kind of different, but the requirements are sort of driven by the initiatives that were done. So in healthcare, I see a lot in this, that stateful behavior emulation becomes important because of the complex workflows involved in entitlements and patient profiles, and then the security of data becomes important in this. I see a lot of EDI showing up in healthcare because they're using the electronic data interchange format to negotiate with backend systems. So there isn't one necessarily right answer to say, these are the things you're going to need in service virtualization. It's going to be what you are doing as an organization and having a checklist to say, okay, these are the types of capabilities that are going to be important to us. Let's make sure that we cover those. But probably, as I was going through this, somebody may have identified as being in one of these verticals and said, hey, I'm in the healthcare sector, but you said that I don't need file transfer virtualization, or I don't need authentication. There is no one blueprint for each one of these different areas. So it's really important to take an inventory of what things are available and then customize it. And then as you start looking for your solution, just make sure that it's checking all the boxes for you. So from a required features and capabilities perspective, I think this is a good comprehensive list of those things that you should be looking for. But to maximize return on investment, your service virtualization solution should focus on 4 key capabilities. Rapid service creation, and that is the ability to build a virtual service that has all of the same behavior and logic of a real service, and as quickly as possible. Because quite often what happens is that you'll require a virtual service when you have a challenge in your test environment. And you don't want to be spending the time to investigate and learn all of the domain logic and business rules of a service. You want to be able to rapidly build that, swap it in, use the virtual service, get past the problem. And that's going to be one of the critical enablers to drive adoption at the organization. Hey, that virtual service showed up, it helped us do what we needed to do, and we should use that more in the future. And that's going to be one of the most critical capabilities. Second is breadth of technology. Virtual services are like snowflakes. Every single one is different. It's akin to the types of services, real services that we have at our organization. We'll very rarely have 2 services that are doing exactly the same thing. Everyone's a little different. It has a slightly different way that you interface with that. And it'll have a slightly different technology. And so being able to have the correct breadth of technology for your key initiatives will be critical. And we'll dig into that a little bit. Third is broadly accessible architecture. Different users are going to want different access to the technology. They're going to require different power from the tool, all the way from simple ad hoc usage from your community of practice, all the way to fully scalable, complex virtual services from your center of excellence. And your solution needs to be able to accommodate both of these types of users in the same infrastructure. And then finally, and I think one of the most critical pieces is change management. Services change every single day, so will your virtual services. And I've seen many initiatives fall apart because they did a great job up front to create the virtual services they needed. They didn't have the change management processes in place for automated healing of those virtual services. By having change management, you'll be able to build a long-term library of reusable services that you can trust and know that you'll have the right version for your particular initiative. Okay, so let's dive into each one of these with more information. So rapid service creation. So as we're working in our environments with our applications, we may be adding, new features, new functionalities to them. And quite often what we can see is that we'll lose a lot of time based on unstable environments, which really, as I talk to a lot of my users, it's not necessarily the environment that's unstable, but it could be a couple of key pieces of technology, a database, a mainframe, a tricky service, or something that somebody else is working on that it never provides you what you need as you're doing local testing or local development. And so by being able to identify those areas, be it a back-end component or something that's rapidly evolving, you need to be able to rapidly create a virtual service to support that. And so this is where you're going to want to focus on technology or a service virtualization solution that has key service creation workflows depending upon how much of the service you have knowledge for. Your service virtualization solution should be able to automatically create the virtual services using service definitions. This is one of the best ways to build a virtual service as soon as possible, because quite often in development, that's the first thing that you'll have available when we decide that we're going to build some APIs. You should be able to take that service definition, whether it's a Swagger or an OpenAPI 3, or being able to take a WSDL or whatever, even a fixed length data model or a copybook, be able to take that definition and convert that into a virtual service. And you can provide it with the data that you need for that particular use case and immediately become unblocked, no matter how far along the actual service is. Now, going forward, you're going to want to be able to capture the logic and the data of that virtual service. So your service virtualization solution should have the ability to create virtual services through record and playback. I actually think this is one of the best ways to build virtual services because you get a lot of things at once. You'll go ahead and you'll get the all of the definitions for how the response should look, the schema, as well as being able to get the logic in that virtual service, because by recording the requests and responses, you'll get those pairs, and you'll be able to use things like intelligent correlation to make links between the request and response so that it understands what pieces of information came in, how do I correlate on those, how do I then send a response that's unique for each of the individual requests. And so being able to have those different capabilities, as well as being able to just simply build them by hand in a very non-scriptless way, will allow you to spend less time configuring the service and more time using it. And this is one of the most critical enablers that you need to look for in your virtual service solution, is how fast can I build a virtual service? And does it comprehensively do what I need given what is potentially a very complex service that I'm simulating? Okay, so that's rapid service creation. Let's talk about breadth of technology. So we always hear this. There's many message formats and protocols out there in our industry. Well, what does that mean? Well, it means that when you're creating a virtual service, you're going to need to communicate over some kind of a protocol. HTTP, HTTPS for REST, but you could have queuing technologies like MQ, JMS, RabbitMQ. Some of the technologies that you'll see on this list. But we also transfer things via TCP and file-based, and potentially over other non-standard interfaces like some of the IoT and microservice ones we're seeing. Kafka is a good example. And these are constantly changing, and it depends upon, as an organization, what technology you've implemented in your environment. Well, your service virtualization solution shouldn't care. It should be able to abstract the communication mechanism that you're communicating over from the message that you're trying to send, so that you can support a wide array of different technologies without having to constantly write new implementations or new logic to support, the next protocol that comes up. And on those message formats, there's a whole bunch of those. You could be using something like JSON with your REST services or XML, maybe XML again with your SOAP services. But when you're virtualizing things, typically you're going to want to virtualize the complex backend systems, the things that would be communicating over maybe a queuing technology, or maybe a JDBC database, or maybe some of this ISO 8583 or copybooks technology that you might see on your mainframes. You're going to get a lot of return on investment virtualizing the more complex legacy technology than potentially just simulating REST and SOAP services. So you're going to look for a solution that can support whatever your message formats are. And these can manifest as web services. So again, could be RESTful SOAP services, maybe having attachments, or depending upon how you've implemented them. Or they could be microservices that are communicating over those specific protocols and message formats. And at the same time, on this whole stack, you also have all the data that's powering those. And that can either come from actual databases, or when you're starting to build that into your virtual service, you may want to leverage your own data sources, such as Excel, CSV, databases, or maybe generate the data on top of that. Your service virtualization should be able to understand what's important to you, but also be extensible so that as new technology comes along, you don't get stuck. And so a good application of this we see is when organizations set out to implement service virtualization. Breadth of technology becomes one of those blockers that requires a bit of homework. The idea is that I need a virtual service when it's critical. But if I need to, let's say, virtualize some COBOL copybook over MQ, do I have to spend the time figuring out all the intricacies of how that interface is different from, say, a REST interface? So there's a high cost associated with that and implementing the right business logic. And potentially, maybe the solution that you have doesn't have that interface that you're trying to virtualize. And so you have two options there. Build a custom implementation yourself, or start investigating a brand new technology to cover that. This ultimately ends up manifesting in not only training on how to use the new solution, but also in training how to understand the new implementation. What I see a lot when it comes to this technology challenge is that an organization will say, I can do this with a whole bunch of different tools. I can accomplish this with this guy over here. I can accomplish this with this tool over here. And then they end up having a whole bunch of different simulation and mocking and stubbing and different, everybody's using something different, and it ends up being fragmented across the organization, which means that when you are trying to reuse these different services, it's difficult to, consolidate everything together. So the solution is to look for a service virtualization solution that supports those message formats, protocols, technologies that your organization is using. And this, I think, can be one of the most critical exercises that you do when choosing a solution. Take an inventory of the different message formats and protocols you have. Maybe copy the list from what we're going to provide you from this webinar, or just take an inventory yourself and say, okay, what things do we have? What things do we want to virtualize? And let's make sure that our solution not only has them, maybe built in, but also potentially provides us a easy-to-use extensibility framework so that we can add that new capability in. And that way we're covered for today's technology, as well as whatever is coming down the line. I mean, who knows what's happening next? Okay, so that's your breadth of technology. And so focus on a service virtualization solution that enables you to create services across a changing landscape of technologies. Okay, breadth of technology. So let's talk about now that we understand how to rapidly create a service across multiple message formats and protocols, what becomes important next is ownership and usage. And this manifests as an accessible architecture. Now, many organizations will bring in service virtualization at the very beginning and say, we have this problem, and I'm going to simulate it with this technology, and hooray, we did what we needed to do. Everybody kind of cheers, and then you kind of walk away from it a little bit because the problem has been solved. And then an organization later on goes and looks and says, why aren't we using service virtualization? And it's because different users have different requirements. And as your organization grows, this starts to manifest. And so a service virtualization solution only, works the best when the organization is all in. It means that there's a commitment that we're going to use service virtualization across these different areas: performance, early stage development, maybe some prototyping. We're going to use it in our test environments for stability. We've decided across the board we're going to do that. So how do you use that? Well, your community of practice, that is federated users who just want ad hoc usage. Maybe I just want to build a virtual service to unblock myself for this little development project I'm working on. Maybe I need a virtual service to simulate a quick database for testing. I don't really want to be involved in the huge service virtualization initiative at the organization. And therefore, I'm looking for simple browser-based or simple access to service virtualization. I don't want to install something on my desktop. I just want to use it. I want to get in. I want to get out. And those folks will need that. Well, at the same time, your center of excellence, those who are responsible for creating the daily virtual services that are powering our critical applications and the daily maintenance of those virtual services, will need their powerful desktops so that they can create all sorts of different virtual services using different technologies. You want to be able to power both of these teams, but without having a consolidated platform that's linking these two teams together, you're going to have a lot of redundancy. Different teams will be creating different versions of potentially the same service, or maybe having to spend time researching a service that's already available. And so look for a solution that has a centralized authority or a thread that ties these different types of users together. And allows you to create virtual services in both different ways, and they're the same virtual services so that reuse can take place, and you can search for virtual services that may have already been created, understand why they're there, who created them, what they're used for, but then have the ability to kind of swap them out. And so you'll need this centralized authority to coordinate these two activities, while at the same time managing the deployment activities of virtual services either into your cloud containerized environments or into your on-prem solutions. So this is a good architecture to enable not only widespread usage, but to allow that solution to be adopted more, because the barriers to entry become significantly lowered when you don't necessarily have to install something heavy, but you still have that power when you need it. And so this helps you ultimately scale the adoption, but also not lose any of those virtual services that you've created. So you need a highly accessible and collaborative architecture. And a good solution for this is a continuous testing platform, which allows you to have a virtualization, browser-based thin client, simple to use solution for infrequent users, while at the same time providing that powerful desktop for daily users and linking it together so that you can search for your services, configure those services, deploy those services, and test data all to the teams without having everybody have to pile into one particular solution. And of course, source control is going to be a huge piece of this. You need to have native support for source control, because on top of the sharing, you're also going to have different versions. And maintaining those different versions, these are what source control systems are built for. So look for a solution that natively integrates with a source control system. Okay, so that takes us to our final area, and that is change management. For this one, I want to tell a little story. I work with a lot of service virtualization initiatives at different organizations. And one in particular that really struck me was an organization that had really bought into service virtualization. They were doing great and amazing things with it. But they had this challenge that they didn't realize actually was an opportunity for service virtualization. And what I saw was that the testing teams were interfacing with applications, and those applications were connecting with potentially third-party or partner APIs. And what would happen was that periodically that partner would then go and say via email, hey, we're creating a new version of the service. And here's the service definition and a couple of one-line statements that says this is what the new service is going to do. Well, it just wasn't enough for the testing teams to understand how that would affect their current tests, how that would affect their environments. And so quite often what management decided was to say, hey, step back from that project for some time until the new version becomes available. And then when that new version is deployed, we can then start running our tests, see what breaks, and then fix the tests. It's a really slow process, but it was the best that they had at the time. And this is actually an opportunity for change management through managing the change in the service. So look for a service virtualization solution that understands the structure of the response information from not only a static model, but also is tied to the service definition, to the schema, to the model of what that response structure is. Because what that will allow you to do is to analyze that structure against a changing definition. And so the idea is that if you as a part of maintenance, maybe daily or nightly, execute a change impact analysis against your virtual services and delta them against the current service definitions. This will help you understand when change has occurred, what is going to change, and how is that going to affect your virtual services. You can then do two things. One, create a template that allows you to update any virtual services that you have to the new definition, and then leverage those virtual services as prototypes of the new definition in your test environments. And this is exactly actually what this organization had done, is every time that new change was announced, they just created a virtual service. They went through the change management process, which is an automated workflow, dropped in the new virtual service, used that as a prototype until the new version became available, and then you don't have to wait. And so this allows you to manage individual virtual services and guard against a changing ecosystem. But you can actually take this one step further, because change takes place in your data as well. And being able to understand the response of a service and how that maps to the underlying data will help you maintain it will help you maintain your virtualization initiative while at the same time helping you approach a test data initiative. By creating virtual services that allow you to remove the bottleneck from centralized data objects such as databases or common services, those individual services now have their own data. And if you have an opportunity where some data is changing, but you're waiting for that ETL job or that batch job to kick off and put the new data into the test environment, having a change solution that allows you to not only model what the data looks like in your virtual service, but also to generate and extend and inject that data with the new definitions that are showing up, will allow you to have a service virtualization solution that not only manages change, but actually becomes the most proactive agent in the change process, allowing you to get ahead of service change and get ahead of data change. So look for a service virtualization solution that allows you to do both, manage the service change and the data change. And so one piece that's really important in all of this is that service virtualization can be a critical enabler in your DevOps process. And I mentioned a continuous testing platform. And I know that that's somewhat of a overloaded term, but I think that it breaks down to this. Service virtualization is more than just simulating a service. You can do that, and it will provide you some value in being able to have stability in your test environments. But service virtualization, the right service virtualization solution can do so much more. You can use service virtualization as a part of your automated testing so that you can make sure that you're stabilizing those test environments, but also as a part of your CI process so that as code is being checked in, you're dynamically deploying those environments, which is allowing you to do other things, such as measure the utilization of particular services and be able to build in different levels of reliability into your environment. I'm not going to go through each one of these, but using service virtualization to its fullest extent allows you to significantly reduce the impact of DevOps on your test environments, and it can be a key enabler. So look for a service virtualization solution that's looking to do more than just simply simulate a service. All right, so that was a lot of information. Too long, didn't read. Basically, every service virtualization solution should have the following. But look for a service virtualization solution that's specific to your organization, that has the capabilities that you're looking for, but also focuses on these 4 key areas, because it will make your service virtualization easier to adopt, easier to scale, and ultimately easier to learn. And if you really want to save some time, Parasoft Virtualize does check all of these boxes. It is a comprehensive service virtualization solution that simplifies the process of creating even the most complex virtual services and can be widely available to your organization as both a thin client interface and a desktop. So, I actually see that we have a ton of questions here. For more information in general on service virtualization and Parasoft Virtualize, go ahead and head over to software.parasoft.com/try, and we can get connected with you and give you a whole bunch of information. And so now I'm going to go ahead and dive into our questions and see what we can answer. Okay, so it looks like we actually have some really good discussion going on in the chat here. So a question was asked about the difference between service virtualization and mocking and stubbing. And so I'm actually liking the chat that was put in here by Lakshmi. Thank you for that, Lakshmi. Yeah. So at the most basic level, a mock or a stub is all about a specific dependency. Something that maybe you're doing at the code level, where you are saying, for this function to execute, I'm going to need a little bit of data, come back from this. They're typically static, one-time use. A virtual service is an emulation, it's a reproduction of a component that you have. A mock or a stub typically requires you to understand the interface that you're stubbing, and it's a little bit more of a white box kind of thing, where service virtualization allows you to, with limited domain knowledge, create a simulation of a virtual service that acts in a stateful manner and emulates exactly the different types of behavior, even if it's complex logic that you need. And I think, again, Lakshmi's done a good job of articulating that in the chat here. Let's see here. Let's see. Hi, I'm working at a personal and commercial insurance organization. We're using legacy systems. Which are which of the required features and capabilities? Please clarify. Yeah. So again, if we go back and look at that list, there are just quite a few technologies that we often see in the insurance organization, and quite often you're interfacing with mainframes. I think there's some EDI that comes into play over there. I would say that the key technologies that you're looking for are those that allow you to build a virtual service that can handle those the complex business logic of those, I forget what they're called, like entitlements systems, because little subtle changes to a broker or a provider can significantly change the response object that would then come back to a user as they're looking for their particular profile. And so it's not necessarily going to be the technology, but more, can I create a virtual service that can emulate these different building blocks of logic that I need in order to construct these complex payloads? And so that's going to be a lot of intelligent correlation. That's going to be in a lot of we're going to supply you with a document from this that helps go into response correlation. But a key in a complex system like that is being able to have multiple tiers of logic that allow you to make decisions along the way and change those decisions as your responses are building more and more of the information, and then be able to respond appropriately with a very wide data. Also, data generation, test data generation is going to be key in that, because you're definitely not going to be able to use realistic customer data for their portfolios. And so being able to have a solution with test data generation will be important there. Does Parasoft virtualize support request response pairs? Parasoft virtualize supports request response pairs. Parasoft virtualize actually supports all of the items for asset creation that you see in this list. And so if you have just the request response pairs, you can pop them in there. We can actually analyze a series of request response pairs so that we can understand the relationship of those. So yes. Let's go down a little bit more here. More mocking versus stubbing. Looks like Lakshmi put the information in the chat. Thank you for that. Here's a good question. Can we only virtualize an existing service? If there are dependent systems, how can they be ahead of the curve to test with a virtual service instead of a mock or a stub? So actually, there is a, I wrote a blog on this. It's at the Parasoft blog site. It was about prototyping with service virtualization. Prototyping with service virtualization allows you to take little to no information, maybe just a request response pair, maybe just a service definition, or maybe just if you have information about the logic of the service. You can use virtualization to prototype a service ahead of writing any lines of code. And what this allows you to do is to sandwich the virtual service, sandwich the application that you're trying to build between the virtual service and some data. And so you can say, well, I think the virtual service is going to go like this: drop in a response payload, parameterize it to your data, and then say, well, based on these kind of inputs, I'm going to modify and change the response and sort of make it act like this. Okay, that doesn't quite do what we want, or that's showing a performance impact. That's interesting. What does that mean for the application that I'm interfacing with this? And you can do this sort of back and forth testing and then simulating the response with the service before there's anything available. This is actually a way to enable a little bit of test-driven development with API testing, because by emulating that service ahead of time, you can start building your API tests against the known functionality of it even before the API is ready. Then when the API does come online, you can run those tests against the actual API and say, okay, this is cool. These tests are working the way that I expect. We're building the actual service properly. I feel like that was a really long answer to your question. Lakshmi's asking a question here about how does virtualize implement data persistency? And so I think what you're saying here is stateful interactions. Stateful virtualization is really important in virtualization. You want to be able to have virtual services that can update their data in real time. A good example of this would be a shopping cart. If I'm interacting with a service and I say, give me the items in my shopping cart, I would expect that at the beginning there are no items in my shopping cart. But as I interacted with the system, I would want to put items into that cart so that later on in my test scenario, I would validate the cost of those, the subtotal, the tax, be able to process my checkout. And so stateful virtualization is handled with, at least with Parasoft Virtualize, it's handled by communicating that data from the request and the response into our data storage mechanism. And so you can easily update, create, alter, delete that data just by simply using the virtual service. And it's a tool that you, it's just a little tool that you add to a virtual service that enables that. Head over to parasoft.com for more information on that one. I'd like to know. So yes, there's a lot of questions about mocking versus service virtualization. I think, again, we've got a good answer on that one. Got a question here about dynamic response handling. I think what you're saying is there's two ways that I think of dynamic response handling, and that is when a request comes in, if it has information that I need to use in the response, but it's dynamic, a session token, a GUID, an OAuth token, something like that. I want to be able to then hand that back in the response. Service virtualization, at least through Parasoft, allows you to capture any transient data from the incoming request, whether it's from a header, query, parameter, maybe something in an MQ payload in the body. You can capture that data, store it temporarily, and then use that in your response so that you can simulate that dynamic nature. The other way that I think, what I think of for dynamic behavior is in being able to respond differently to requests that are slightly changing. So for example, maybe I have a REST API that has a path or a parameter or a query that says, give me the book with ID 1, and then give me the book with ID 2. And so being able to disambiguate that request URL and say, well, 1 and 2 are two aspects technically of the same data source in a virtual service. And so what I want to be able to do is to supply a data source that says, well, 1 equals Game of Thrones, 2 equals, The Walking Dead, and then you can dynamically alter, adjust, generate, subset your data source and add in new values without actually altering the virtual service's logic. Okay, so I actually have a product-specific question here asking about if the intent is for Virtualize to be used with our test data assistant or our test data generation framework, or if it has its own repository. So the question is asking, for stateful behavior, are we going to connect that to our test data generation solution, or does it have its own thing? And the answer is, it's the same thing. When a virtual service stores data, it stores it in the test data engine. It's always there. There's no translation, importing, or exporting that you need to do. And so you could respond with that data, update that data, and if you wanted to generate a whole bunch of data on top of it, it's the same data. We don't disconnect those at all. They're all the same. So let me just take a quick look at time here. Okay, let's do about 4 more minutes worth of questions here. Thank you all for the questions. Any questions I don't get to, I will definitely respond to offline. Does the Parasoft tool have a dashboard of the services that are virtualized? Absolutely, we do. We actually have a comprehensive continuous testing platform that allows you to see all your API tests, your virtual services, and actually see the environment diagramming how those are all connected to each other. And that will allow you to turn on and off virtual services, deploy them, reconfigure them, swap their data, as well as come to an agreement on what should be executed as a part of a DevOps flow. So yes, it's an environment management capability. Will database service virtualization will support Parasoft tool? Yes, absolutely. All the items that are checked on this list, plus many, many more. Parasoft.com actually has a technical spec page that will tell you all the different technologies that we support. We do have quite a long list. Okay, that's a database question here. Just on the database thing, I would like to make a comment. I do believe database virtualization is one of the best things to approach at the beginning when you're virtualizing, or when you're trying to prove the return on investment for virtualization. Databases are notoriously challenging bottlenecks in the test environment, and having to dig into them and understand all the different, referential integrity and primary and foreign keys can be really challenging, especially if you're just a tester and you just need a couple of different tables that are built in there. By simulating a database, you'll get really rapid return on investment. And at least with Parasoft, they're really easy to use because you get a nice visual representation of the different tables and how they're connected, and you can just update the data that's important to you. And I truly believe that database virtualization is a great place to start with virtualization. Who should own developing a virtual asset? I want to understand how it fits in within a sprint. This is a great question. So this is all about governance. And so understanding how your service virtualization solution approaches these problems is really critical. I'll tell you, for us, the answer is that a virtual service should be owned by the team that owns the service. Ultimately, down the line, if you want to have a complete enterprise rollout, you're going to need to have those who understand the application change responsible for the virtualization change. And at many of our larger enterprise deployments, there's actually a mandate that when a developer creates a service, they also create a lightweight virtual service. And that obviously gets checked into source control so that there's a correlation between the two. And then the developers can use those for prototyping or testing. And the testers can then say, oh, I'm going to be interfacing with this service today. I'm going to go over to this area where I know that it actually exists, check it out, bring it down, use that virtual service, maybe extend it in a way that I want, but then ultimately the ownership of at least understanding the changes and the logic goes to that team. If you want to put a community of practice or a center of excellence on top of that, I think it's even better, because then you can define your SLAs, policies, procedures, and workflows defined with asset ownership and maintenance ahead of time, and then nobody questions who owns what and who's supposed to be doing what. And if you have questions about that, Parasoft can help you with that, because we definitely have predefined workflows and governance. As a follow-up question, is all the generated data which exists in your test data engine lost when the virtual instance is no? Okay, so the question is, if I use virtualized test data to generate a whole bunch of data for my virtual service, and then I'm using that in my virtual service, and then I'm assuming you're using like Docker to recycle your containers. Does that go away? The answer is no. And that's because it's held within the data repository, and the data repository is what powers the test data engine. So the data is always there. It's always available to you. Cycle your instance, it just stands back up, reconnects to the data repository, and you're good to go. Okay, guys, that was a lot of questions. I really appreciate them. There's many, many more. I absolutely will get in touch with those. Thank you guys for joining today. I hope it was insightful, and I wish you the best of luck on your service virtualization journey. Bye for now.